There's a book out there which called Algorithmic Thinking, and let's make some review. Imagine each concept as a unique tool in your coding toolkit, ready to help you solve problems efficiently and creatively. So let's first of all look up to the hash tables, the magic lookup tool, and where you can instantly, imagine you have a magical filing cabinet where you can instantly find any document just by knowing its title. That's what a hash table does in programming. It allows for super fast data retrieval by assigning a unique key to each piece of data. So when you needed to access something, you simply use its key and press it. You have it immediately. This is especially useful for tasks like looking up a user's information in a database without sifting through all entries. Okay, now let's talk about trees and recursion, nature's blueprint and code. Think of family tree where each person connects to their parents and children. In programming, tree structure mimics this hierarchy, organizing data in a parent-child relationship. Recursion is like a storyteller who tells a story within a story. It's a function that calls itself to solve smaller instances of a problem. For example, to calculate the factorial of a number like 5, a recursive function multiplies 5 by the factorial of 4, which multiplies by the factorial of 3, and so on until it reaches 1. So this approach simplifies complex problems by breaking them down into more manageable pieces. Next one would be about dynamic programming, the puzzle solver strategy. Imagine you solve a massive jigsaw puzzle by focusing on small sections at a time. Dynamic programming is a method where you break down a complex problem into simpler sub-problems, solve each one, and store their solutions. This way you avoid solving the same problem multiple times, saving effort and time. It's like, remembering the solutions to smaller puzzles to help complete the bigger picture more efficiently. So now let's talk about graphs and breadth first search, mapping connections, in other words. Picture a network of cities connected by roads. Each city represents a node, and each road represents an edge connecting two nodes. Graph is structured that depict relationships between pairs of objects. Breadth first search, which acronym is BFS, is like exploring all cities or at the same time, at the same distance from your starting point before moving further. This method helps in finding the shortest path in unweighted graphs, such as determining the quickest route in subway system. So Now let's talk about binary search. It's like the clever detective. Imagine you're searching for a word in a dictionary instead of starting from the first page. You open it in the middle to see if you're close. Binary search uses this divide and conquer approach to efficiently locate an item in a sorted list by repeatedly, dividing the search interval in half. This technique drastically reduces the number of comparisons needed, making the search process much faster. Okay, let's observe heaps and segment trees. In other words, organizing data efficiently. A heap is like a priority queue where the highest or lowest priority element is always at the front. It's useful for tasks like scheduling, where you need quick access to the most important item. Segment trees, data structures that allows you to store information about intervals or segments and query where segments contain a given point efficiently. They are particularly useful in scenarios requiring frequent range queries and updates, such as finding the sum of elements in a range of an array. So now let's talk about union find, connecting the dots. Union find, also known as disjoint set union, which is acronym of DSU. Is a data structure that keeps track of elements divided into disjoint, in other words, non-overlapping sets, and supports union and find operation. It's like managing a group of friends where you can quickly determine if two people are in the same friend circle, and if not, merge their circles. This structure is particularly useful in network connectivity problems, like determining whether two computers are part of the same network. Okay, next one about randomization, embracing the unexpected. Sometimes introducing randomness into algorithms can lead to simpler or more efficient solutions. Randomized algorithms make random choices during execution to achieve good performance on average. For example, the quick sort algorithm selects a random pivot to partition the array, which helps in achieving better performance on average. Embracing randomness can lead to innovative approaches to problem solving. Okay, next one about practical problem solving, hands-on learning. The book emphasizes learning through solving real problems for programming competitions. This hands-on approach ensures that you not only understand the theory but also know how to apply it in practice. By working through these problems, you develop a deeper understanding of how to approach and solve complex challenges, preparing you for real-world scenarios. Okay, and the last one we will talk about from this book about building a strong foundation. In other words, learning by doing. Instead of abstract pseudocode, the book uses actual C programming language examples. This approach helps you see how algorithms are implemented in real world scenarios, making the learning process more concrete and applicable. By coding these algorithms yourself, you build a strong foundation that enhances your problem-solving skills and prepares you for more advanced topics. And by exploring these concepts, you will equip yourself with a robust set of tools to tackle a wide array of programming challenges. I hope it was useful. If you like it, subscribe, thumbs up, and happy coding. See you next time.